Hey there, this is Cody Jackson with Codamom, and we are continuing the Python series. This time we are going to talk about the iPython interactive shell. If you saw my last video, then you saw that we covered a little bit of the vanilla interactive interpreter that Python provides by default, allowing you to test code and look at some different ideas without actually writing to a file. iPython takes what Python provides and really expands on it, providing a lot more features for you and making life a lot more developer friendly. Before we move along, I did have someone ask about the books that I referenced in previous video, and so here are the books that I had talked about: Learn Programming in Python with Cody Jackson and Secret Recipes of the Python Ninja. You can find them on Pact Publishing if you want a electronic version. You can also find them on Amazon if you want a Kindle or a hard copy version. And that is my blatant plug, and we will move on into the lesson. So, why would you want to use iPython instead of the vanilla interpreter? iPython provides syntax highlighting, so if you're familiar with code editors that give you syntax highlighting, you get that highlighting feature with an interactive prompt. It really does make life easier for you if you have a large block of code in an interactive instance and it's all one color. The syntax highlighting helps you differentiate where those certain keywords and things like that are. It has support for Jupyter notebooks, so if you're doing data science, machine learning, anything like that, Jupyter notebooks are very popular, and so that is one of the things that iPython interacts with really well. As a matter of fact, a lot of the code blocks within a Jupyter notebook actually use iPython on the back end. You don't see how it's functioning. Provides interactive visualization, so again, if you're doing some data science, data analysis and stuff like that, rather than running your code and then seeing the output separately, you can call matplotlib and interactively change values within the plot and see how your data visualization changes based off of those inputs. If you are working with concurrency, parallel programming, multiprocessing, things like that, iPython does provide a interactive way to do that parallel development. So you can do a lot of testing in iPython before you put it into your actual code file and confirm that it works without having to spend a lot of time reworking it within the file. Tab completion. So if you're familiar with Bash particularly, you can complete commands by pushing the tab key. As long as you have a certain number of characters, it will give you a suggestion based off of what you have typed in already. It has command history like Bash, so you can go back and you can see previous commands that you have typed in iPython and call them again and again and again, so you don't have to keep typing the same thing. Obviously, that's very useful if you have a large chunk of code or commands that you want to run and you don't have to keep typing them every time. Object exploration is basically allowing you to look at the internal documentation of data structures within Python, so you don't have to pull up a separate Python documentation window. You can pull that information up straight within iPython. It has a thing called magic functions. Magic functions are built-in macros that iPython uses to provide special features that would otherwise require you to program your own functionality and then incorporate it into your program. With magic functions, you don't have to do that. And finally, it offers direct access to your operating system shell commands. So rather than having two terminal windows open up, one with iPython, one with Bash, you can have iPython as your main environment and just call out to the operating system as needed if you need to, for example, ping a distant end node. You don't have to drop into Bash to do that ping command. You can just call it directly within iPython and then use that data further in your testing. So we're going to go and play around with the iPython shell for a little bit just so you can see how it works. One thing I wanted to point out in the iPython documentation, all versions of Python below 3.3 and to include 3.3 have all basically been deprecated, as you can see right here. So if you're using iPython and you're using version 6 or greater, you have to use Python 3.4 or greater with that environment. If you want one of the older versions, then you're going to have to look at one of the iPython version 5 releases. So we're just kind of going to go through the main features of iPython and just kind of demonstrate how it works. So you'll notice, if you remember in my prior video where I had to use Python 3, same thing with iPython. You can designate iPython 2, iPython 3, depending on which version you're using. In this case, I wanted to drop into the latest version of Python, so iPython 3 gives me Python 3.8. Now, you'll notice that the very first thing that's different, other than the header up here that tells you that you're in the iPython environment, is the prompt. It's not the 3 arrows that you see in the regular Python interpretive shell. In this case, you have a line number 1, and it's telling you that this is input. So this is what you're going to be typing into the prompt. And you'll see that we already get syntax highlighting based off of what we are typing. So print is a keyword function for Python that's built in, and so that's highlighted in green. Hello world is a text string, so that's brown to denote that that is a text string, and then the parentheses are in yellow, so you can easily see where your open and closing brackets are for certain data structures within Python, such as functions or tuples and things like that. So if we hit print, then it spits it back out to the next line with a hello world, and then drops us onto the next line number. If you want, you can type the question mark, and that gives you the iPython help, which is basically everything that you would find over in the main documentation. It just happens to be here in the terminal window for you to look at. To read it, all you do is just push the space bar, and that moves to the next page. When you're done reading, you hit Q to exit. So say I wanted to import a module. I could type import, oops, and maybe I want to import random. All I do is type the first couple of letters, and then I hit tab, and it automatically completes it. If I type some more, then and hit the tab button for the tab completion, then it pops up a little window showing you the different options that you have. In this case, I did random.rand, and the options that I have available to me are rand_int, so random integer, random.random, and rand range. And so you can choose which one of those that you want to bring in, hit the enter key, and it puts it in there for you. In this case, it's telling me that random.randint does not exist as a module because random is not a package. If you get an error, it lets you know that there's a problem because it highlights it in red, and it tells you exactly where it was and what that problem is. Obviously, you'll get the same type of information from the regular interactive prompt, but the color coding should help you in identifying immediately if there's a problem when you're running your code. In the iPython documentation, there is a tutorial section. Highly recommended. Just kind of go through it, get comfortable with what iPython provides for you. It even talks about using Jupyter notebooks and a lot of features that I'm not going to cover in this video. So we'll just take a look at the at the example right here, and you can see what the output is. So we've already done the print statement or the print function hello world. If you want to do some mathematic calculations, you'll see that you can type it in like a regular Python interpreter, and it will give you the output if it has been processed. So up here there's nothing to process, it was just a print string to the terminal, and so there was no out line. For line 4, it did give us an out in a different color because it actually did some processing, and so it's indicating that that processing was accomplished. If we want to create a function, as in the example, if you remember from the previous video, if you went to the next line while creating a function in the interactive prompt, it did not auto-indent for you. That's one of the main advantages I've found of using iPython, is that it does provide that auto indentation for you, which is very helpful. So this was a fault on my end, but again, it shows you the how errors are processed within iPython. Again, where the problem is highlighted in red, and it tells you what the problem is. In this case, I forgot to close out the quotes. So again, up arrow gives you your previous command, much like bash, but if you're doing that in the regular Python interpreter, it does it strictly line by line, not block of code by block of code. So if I did this in a regular Python prompt, it would have gone up to the print line, and if I pushed it again, it would have given me def say hello, and rather than that entire block. Again, one of the benefits of syntax highlighting, had I been paying attention, the fact that the dot format up here was brown would have told me that I did not close out the quote here, because as soon as I did that, the dot format section turned yellow to tell me that I had properly closed it out. So back to the regular command prompt, and if I call the function that we had just written, again, you can use tab completion, and it knows what it is that you want to complete. In this case, there is no built-in say hello function, so it defaulted to what I had given it, and we'll just put in my name there, and it goes ahead and processes the print command and spits out hello Cody. In the tutorial, it talks about the 4 most helpful commands. We've already seen the question mark and what that does for you. Anything that is started in iPython with a %sign is a magic function. And so quick-ref is a magic function that only applies to iPython. Help takes you to Python's normal default help system, and then if you type object question mark, it gives you information about that object. So if I type say hello, because I didn't really give it a whole lot of information, and all it can tell me about the say hello function is that it is a function. This is its memory location. So let's call something that's built into Python. In this case, it's telling us that list is an iterable, so you can iterate over it, so sequential operations. It has a docstring. As I said, we'll talk about it in detail later, but basically the docstring is just built-in documentation about this particular object. In this case, it's telling us that it's a built-in, mutable, so you can change it, sequence data structure. If no argument is given, then it just creates an empty list, and the argument must be an iterable if specified, so it has to be something that can be processed in sequential fashion. It has a type of type, which doesn't mean much to you, except for the fact that if you see that this is a type here, and then this up here, our say hello, was a function. And then there are different subclasses of list that you can use for different purposes. So that's just an example of the question mark that iPython provides to you. So I've talked a couple of times about magic functions, and I did talk about the time it magic function. So we'll just go ahead and we'll play with this real quick. If I do in the example time it range 1000, so all that's going to do is just create a sequence of digits to 1000, and the time it is going to tell us how long it takes to create that range, but it's going to do it multiple times so that we can get an average of what a reasonable time frame should be for an individual loop. In this case, it's telling us that it took 149 nanoseconds on average to process 10 million iterations of range 1000. So 1 to 1 or 0 to 999, and it did it 10 million times, and it gave us what the average was to do that that calculation. Per the example, if we do it again, and except this time we're doing x equals range 10,000, and then we get the maximum value of x. In this case, it's going to take 231 microseconds, so it's a little bit slower than just doing a straight up range, and it only did 1,000 loops instead of 10 million loops. You can control how many loops it does, but Python has an equation or an algorithm in it that determines what the best number of loops to do for your particular process. So you can look over here. It has line magics and cell magics. Line magics are what we've been doing over here. It's on a line. Cell magics are prefixed with the double percentage signs, and they are functions that encapsulate everything within that code block. So whereas this was a single line, if I had hit enter and tried to do something else, time it would not capture it. But by using double percentage signs here, it went ahead and recognized that not only do I want this portion on the same line, but I also wanted the rest of the code below it. And so you have to hit the enter key a couple of times for it to recognize that you are out of that code block. So you can go through the tutorial and see some of the other magic functions that are available for you. And there's actually an entire section in the documentation that tells you the magic functions that are already pre-built into iPython and how to create your own if you want to. I talked about one of the benefits of iPython being a history. So if we type in history, then you can see that iPython, much like Bash, has kept track of everything that we've done in this particular session and is going to give it to us in this listing of previous commands. And again, if you look in the documentation, you can see that there are special magic commands that you can use to call different portions. So if we want to rerun a command, all we have to type is rerun with the %, and then the line number of what it is that we want. So if you want to rerun line 1, which is just to print hello world, it's going to re-execute it and then give us that output. On the other hand, if you just want to see what it was that we used rather than actually running it, you can do recall, and that will give you what you'd actually typed in at the command line. You can access any command from the Bash shell simply by using the exclamation point. So if we want to run the ping command, then exclamation ping google.com, and you can see that it's going through and it's running a series of pings against the google.com website. And you can do this for any operating system command that you can think of for the Bash command. I haven't tried it on Windows. I cannot say how it integrates with PowerShell. You can define certain shortcuts, aliases, whatever you want to call them, so that you don't have to either call a series of commands every single time, or if you want to merge several other commands together, especially magic commands, you can create an alias that's basically a macro. You can configure how iPython works by looking at its profile and changing various features in that. There are some startup files that you can set up to automatically run whenever you launch iPython. And so there's also a section on rich output, which is really the data visualizations that we talked about using matplotlib. I'm not really going to drop into this right now. We'll take a look at visualizations later. But if you get into data science and stuff, you'll see that this percentage matplotlib command is very popular in Jupyter notebooks and other environments, because it basically allows you to call the interactive plotting feature of iPython very easily, and you don't have to do a whole lot of configuration for it. Further in the documentation, you can see that there's a lot more information about how to use iPython. You can set it up as your default Python environment. You can embed it into other programs, a variety of interactive demos that you can play with. There's really a lot here, and I really don't want to bore you with all the details. Plus, as a budding programmer, it's good for you to learn how to read the documentation and play with the examples and learn how the code works for you in your particular environment. What I'm showing here may not work exactly the same in your environment, particularly if you're in Windows, because Windows is not Linux or Unix based, and so some of these commands may work a little bit differently. So moving on a little bit, I want to talk about the Conch shell. So Conch is an alternative to the Bash shell. And like a lot of stuff in the open source world, it's a play on words. The X is actually the Greek character chi, and so that's why it's pronounced Conch. So Conch is actually a Python shell for Linux. So basically, if you don't want to use Bash at all, you can use Conch, and it uses Python 3.5 as its underpinning environment. It has a lot of the Bash shell functions, but you can also use just straight up Python right at the command line, and it will work for you. So rather than dropping into iPython or a regular interactive prompt, you can type all of that Python code right at the command line and get the results without having to have separate environments all the time, like we talked about, having iPython and Bash to do the ping. You can do all of that within the Conch shell. It also allows you to gain direct access to the operating system, similar to how iPython does it, but it's a little bit more integrated and not as clunky. So theoretically, you could replace all of your Bash scripts with just pure Python scripts. The only problem with it is that it is an uncommon environment, and so if you're not always using your own computer every time, if you do have to work with another computer that only has Bash, potentially you could be lost because you're used to using different commands. Especially if you are constantly dropping into Python to do automated scripting or whatever the case may be, and you can't do that in Bash. You would have to make a Bash script to do the exact same thing, or make a completely separate Python script and run that separately from the operating system shell. That's really all I'm going to say about this. You can find the Conch shell online. It does have an interactive window within the website, so you can play around with it and see how it works. But it's really up to you whether you think that it's better versus the regular Bash, or if you just want to maybe use iPython and occasionally use Bash commands, or if you live in Python, 24/7, and you want that functionality available to you. So that's it for this video. I really just kind of wanted to jump into iPython, give you a brief rundown of it, especially as we do future videos. I will use it fairly often for quick and dirty examples, and I just don't want you to be confused about what I'm doing or how I do it. We looked at the advantages of replacing the regular built-in vanilla interpreter that Python provides you with the iPython environment, viewed how iPython works, some examples of how to use it, and then we talked about using the Conch Shell as a replacement for Bash. In our next video, we are going to look at the built-in Python data types and actually start to get into some actual coding. So if you've been bored up until now, hopefully the next video you'll start to get excited and start to see some of the stuff that Python can do for you. Until that time, have fun and continue learning. Thanks. Bye.